Welcome back to another volume video, everyone. And in this one, we'll be looking at the volume of pyramids, cones, and spheres. And we're going to see that when we're given the formula for these, all we have to do is plug in the right values in the right places. Sometimes maybe use a Pythagorean theorem here or there to figure out certain values, but we are not really introducing anything new. We are applying what we've already learned into a different formula. So let's go ahead and jump right in. So in your formula booklet, for the IB at least, with AISL, you'll find that this formula is given to you, which is that the volume of a right pyramid, meaning that we have a square base and then a height that goes right to the middle, is going to be 1/3 the area of the base times the height. So if my base here is going to be a square, well then my volume is going to be 1/3 times 4 times 3.5, because that's going to give me the volume of that square, times my height, 7.4. And I will find that my volume is going to be 34.5 cubic centimeters. Pretty straightforward. Now let's say I want to find the volume of a right cone. So I'm given that the volume of a right cone is going to be 1/3 pi r squared h. And if you notice, it's essentially the same thing as this formula up here. It's really just the area of the base, which in this case is a circle, so it's pi r squared times the height. In this case, I don't exactly know the height, but based off our other problems that we've known, we should see that this right here is a right triangle. Knowing that, I can use the Pythagorean theorem to figure out my height. So I know that 11.5 squared is going to be equal to h squared plus 3.2 squared. So the root of 11.5 squared minus 3.2 squared is going to be equal to h. What is that going to give me? H is going to be 11.04. Let me check my calculator again. 04515. And that's going to be quite long. Remember, when you're doing these calculations, you want to use the actual answer, not the rounded answer, in your calculations. Save the rounding and the significant figures until the end. Now, knowing that the height is that, well, I can now figure out what my volume is, because I know that the volume is going to be 1/3. That is one of the worst threes I've ever made in my life. There we go. Times pi, and we have r squared, which is going to be 3.2 squared, times the height, which is 11.04515, blah, 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 blah. Again, when you're using a calculator, you can store that to a variable, or you can just hit the ANS, the answer key. So I'd find that my volume here, once I kind of put this all in my calculator to three significant figures, is 118 cubic centimeters. All right, so not too bad. That one, we had to do one extra step with the hypotenuse, but again, not the hypotenuse, to find the h value. I guess you also using the hypotenuse. But we needed to use the Pythagorean theorem to figure out that missing side. So we're just using what we learned before in a new light. So let's take a look at an example that might seem a little bit more involved, but as long as we follow the same steps, we can go ahead and figure out what this is. So we're given that a cylindrical can is going to hold 3 tennis balls, and each of these balls has a diameter of 6 centimeters. So from here to here, going through the middle, we're going to have 6 centimeters. Right? What does that mean? That means that the radius is going to be equal to 3. All right, so which is the same diameter as the cylinder. So the cylinder also has a diameter of 6, and the cylinder is filled up to the absolute top. So let's calculate the volume of space in the cylinder that's not taken up by the tennis balls. So it's similar to kind of some of the sector problems that we've covered in previous videos. We're going to be finding the volume of our largest shape, which in this case is going to be the cylinder. Then we're going to find the volume of these 3 tennis balls, because if we subtract the volume of the 3 tennis balls from the overall volume of the cylinder, well then whatever's left is just what isn't those 3 tennis balls. It's going to be the space that's left over. So the volume of, let's call it space, it's going to be equal to the volume of the cylinder minus the volume of the 3 tennis balls. All right, so now that we know what our equation is to figure out the volume that we're being asked for, let's go ahead and use our new formula here, the fact that the volume of a sphere is 4/3 pi r cubed. And we already know what the volume of a cylinder is. It's the area of the base, which is pi r squared times the height. And let's go ahead and solve for this. So the volume of the space is going to be equal to the volume of the cylinder. So that was pi r squared, 3 squared, times the height. So this isn't directly given to you, but you know that this diameter is 6. So let's say the diameter started down here because the ball touches the bottom of the cylinder. It's going to go up 6, and then another 6, and then another 6, because each of these 3 balls has a diameter of 6. So 6 times 3, That's going to be 18, minus the volume of the 3 tennis balls. So 4/3 pi r is 3 cubed. There we go. So if you put that in your calculator, so I'm going to go ahead and do like one step by hand. I'll get an answer of 162 pi minus 108 pi. So again, it depends on whether or not you want to keep it in pi as exact or if you want to give an actual like numerical approximation for the volume. So if I did want to go ahead and do that, and I wanted a numerical approximation, I would find that the volume of the space can be approximated to 169 cubic centimeters. Go ahead and mark that. So again, it's just recognizing that if we find the volume of two different things and subtract one from the other, well, we get what's left over. Okay, so I hope that helps shed a little bit of light into how some of these problems might seem a little bit more complicated, but we can use the same exact approach as we have done before in other problems and use some of our previous knowledge of the shapes and volumes and surface areas and whatnot to solve new kinds of problems. So hope that helped, and I'll see you all in the next video.